Hello everyone, welcome to another online class. So today we're working on application of sinosodial worksheet. So I will do 2 questions for you, and there is 3 questions I'm expecting everyone to work on. First, this is the question. Weight is suspended from a spring. Weight is pulled down 3 centimeters. So everyone knows what is the spring, right? So if this is like that, this is like the spring. This is the weight. I pull it down 3 centimeter. So it started going up and down, right? So it's going to be sinosodial model. So from the information, it said at 2 seconds, it is 3 centimeter above equilibrium. Equilibrium is going to be the position that your spring is at rest. This is the equilibrium. So I'm just want to roughly graph this for you guys. So at the beginning, you pull it down 3 centimeters. Means at the beginning, you are 3 centimeters, your object is 3 centimeters below the x-axis. At 1 second, it go back to equilibrium. So this is the 1 second. Equilibrium means 0 position. It's here. 2 seconds, it's gonna be 3 centimeters above. 1, 2, 3. So it's here. And at 3 seconds, again it go back to equilibrium, as you see in the information provided. At a 4 second, it will be 3 centimeters again below. So there's gonna be there. As you see, this shape is look like sinosodial, and it's gonna continue, but I don't want to graph the rest. So the equation for this, everyone know the general equation of this graph. Y is equal to a sine or cosine. Here I prefer the sine because this is start at minimum, or if this is start at maximum, it would be preferably is cosine. Cosine k x minus d plus c. So first of all, the c here is the axis of symmetry. Is obvious. This is 0. A is amplitude. Everyone know the amplitude is the half the distance between the maximum and minimum. So if you want to find A, it's going to be max minus minimum divided by 2. So as a matter of the fact, so we take absolute value of that. The maximum is going to be 3 minus the minimum is negative 3 divided by 2. It's going to be what? 3 again. So this is the amplitude is 3. Also, I need to find k. K is equal to 2 pi over the period. So what is a period of function? The period is the length of full cycle. The length of this full cycle is 4 seconds. True? So from minimum to minimum, or from maximum to minimum, maximum to maximum, or any symmetrical point to another symmetrical point. This 2 pi over 4 is pi over 2. What else I need? The phase shift. Phase shift here is 0. If I say that this is my cosine look like this. This is flip of cosine. If I want to write down the equation, because this is flip of cosine, become negative. The A is 3. A is 3 cosine of k, which is pi over 2 x. That's it. So plus 0. So I don't write the 0 here because the c was 0. So this is my equation. So it's asking find the distance of the mass equilibrium position at 50 seconds. For part B, you just sub 15 for x, and I'm sure everyone has the calculator. Just put it in your calculator. So it's just going to be the position. Now, this is the first question. The second question is on a worksheet that you will see that is a Tarzan. Tarzan is swinging back and forth with the rope in the jungle, and someone recording his position. So at 2 seconds, Tarzan is at the end of swing at y equal to negative 23. Means it is a minimum position. At t equal to 5, he is at the other end of the swing. Y is equal to 17. So it's going to be maximum. A sketch graph, write the equation. So again, I want to just do a roughly graph of this. So again, it said at 2 seconds, he's at negative 23. So let's say this is 2 seconds. So I go, this is 10. This is 10. It's negative 20 is here, negative 23. So at 2 seconds is approximately here. At 5 seconds is at 17. 1, 2, 3, 4, 5. So this is 2. 3, 4, 5 is at 17. So it's 5, 10. So it's roughly here, which I'm saying that this is 17. Now, this is minimum, this is my maximum, right? So a little notes here. So when we have a maximum and we have a minimum, right? The period, it's kind of, if this is, let's say, 1, 2, 3, and here's 4, right? He's dividing, any sinusoidal function has 4 equal parts. So from maximum to minimum is 2, right? Maximum, minimum is going to be half of the full period. That's why here, if the distance between the maximum here to minimum is 3, the full period going to be what? 6. So period here is going to be 6. So, and I know that if this is 4, so we have a 4 equal part. Again, the same thing. I have four equal parts for this period here. So each part is 1.5. So means from this minimum, if you go 1.5, you will get to the equilibrium or the axis of symmetry. Okay, let's just put axis of symmetry first. We call it C. The axis of symmetry, everyone know that is going to be the midpoint, is going to be maximum plus minimum divided by 2. So my maximum is 17, my minimum is negative 23. Okay, divided by 2. So it's going to be what? Just doing a little calculation. Is 6. Okay. So it's 6 divided by negative 6 is going to be negative 3. So my axis of symmetry, if I want to put that, is going to be negative 3 is roughly here. I put it as a dotted line. Right? So this is negative 3. So as I know, if this is 2, you go forward 1.5, you get to the axis of symmetry. And you go forward 1.5, you get to the maximum. You go forward by 1.5 again, you get to the other side. So I can do the backward, right? I go by 1.5, I get to the axis of symmetry from this side. So if I do that, actually, let's just do 1.5 is 5, 6, let's say that's there. I get to the axis of symmetry again. So this kind of going to be my full cycle. Now I need to come up with the equation. Y is equal to, since this is the flip of the sign, so, and I know the amplitude. What is the amplitude? Again, the amplitude, do a little notes here. Amplitude is equal to maximum minus the minimum divided by what? 2. Half the distance maximum to minimum. The maximum is 17 minus 23 divided by 2. What is it? It's 0. It's 40 divided by 2 is going to be what? 20. So I know the amplitude is 20, but I know this is a flip of the sign. It's going to be negative 20 sine. So for K, again, K is what? k is equal to 2 pi over period. I know my period is 6, right? So it's going to be pi over 3. So I will go here. So it's going to be pi over 3 x minus. So d. What is the phase shift? As you see, this is 0.5, right? So I just put 1 over 2 or 0.5. And x of symmetry, I did calculate that. See this one? The midpoint is going to be -3, right? So it's going to be minus 3 here. So that's going to be my equation. So the last part is, where was the Tarzan when Jane started her stopwatch? Means you find the y position when the time is 0. So I do have my equation. My equation is -20 sine pi over 3. Instead of x, I put 0 because the time is 0. Minus 3. And I'm hoping everyone know how to put that one in calculator and find the position. Anyway, so you go to the worksheet, application worksheet, and doing question number 4, 7, and 10, and send it to me. So this is of sinosodial function worksheet. So do that and send it to me.